This last problem is going to be the net ionic practice. So these are those long multi-step problems where it starts off like a double replacement, but then you have to add on the complete ionic equation and the net ionic equation. So the first thing we're going to do is we are going to go ahead first and write out, we know that we are going to have compound plus compound, and we're going to get a compound plus a compound. So what we need to do is we need to be conscious first of the charges for the different reactants that were given. So sodium carbonate, sodium has a +1 charge, carbonate has a -2 charge. So when we crisscross those, we are going to get Na2CO3. For the second one, you have magnesium sulfate. Magnesium has a +2 charge. Sulfate has a -2 charge. So when you go ahead and crisscross those, since it's +2 -2, those are going to reduce. So you're going to end up getting just MgSO4. Now, just like we did with number 4 on the worksheet, we're going to switch the anions to get our products. So to do that, we know that the first product is going to be sodium, which has a +1 charge. But now instead of carbonate, it switches, and we're going to have sulfate, which has a -2 charge. So when we crisscross those charges around, we are going to end up with Na2SO4. And then for the last product, or the second product, we know that we're going to have magnesium, which has a +2 charge. And then that's going to be combined now with carbonate, which has a -2 charge. So when we crisscross these, we're going to end up with MgCO3 because that +2 -2 reduces and cancels. So what we want to do next is we want to balance this equation. So when we look at this, we're going to look at there's 2 sodiums over here on this reactant side. There's already 2 sodiums on the product side. You have only 1 carbonate here. You have 1 carbonate on the product side here. 1 magnesium on the reactant side. 1 magnesium on the product side. 1 sulfate. 1 sulfate. So what's great about this is already balanced. Now, the next thing we have to do after that is we need to figure out states of matter. So this is when you guys use that solubility chart. Remember, you are going to get that on the test and eventually on the final at the end of the semester. So when you're using the solubility chart, you have to find one part of the compound in that very first column. So when you're looking at Na2CO3, sodium is a group 1 element, and it says that all group 1 elements are aqueous, and there's no exceptions to that. So we know for sure this one, AQ. For magnesium sulfate, you can see sulfate in that first column. It says that sulfates are aqueous. There are a couple of exceptions, but magnesium's not one of them. So this one is also going to be aqueous. Your reactants in a double replacement reaction should always be aqueous, but it doesn't hurt to check to give ourselves a little extra practice. So for the Na2SO4, you could have looked and saw that sodium as a group 1 metal is always aqueous no matter what. You also could have looked that sulfates are aqueous, and sodium's not an exception. So we know this one gets the AQ after it. And then for magnesium carbonate, this one, it says that carbonates are always solid. And the only exceptions to that are group 1 metals, ammonia, and ammonium. So this one is going to be a solid. That's the last row on that table. Now, I had told you guys that I think sometimes it helps to put a box around the solid precipitate because when you're doing the complete ionic equation, you don't want to accidentally break that apart into ions. So I always put a box around it to remind myself that that's going to stay as a compound. It's not going to get broken up. So step 2 here is the complete ionic equation. And what we do in this complete ionic equation is anything that has the AQ after it, anything that's aqueous, gets broken apart into its ions. And then we also use coefficients to indicate how many of each ion we have. So for example, this first one, Na2CO3, is aqueous, sodium carbonate. So we're going to write that we have two sodiums. Sodium has a +1 charge. There's only one carbonate with a -2 charge. Magnesium has a +2 charge, and sulfate has a -2 charge. So that's your reactants. Everything's aqueous. On the product side, you're going to have two sodiums with a +1 charge because of that subscript. You are going to have a sulfate with a -2 charge. And then remember, this magnesium carbonate does not get broken apart because it is our solid precipitate. So we are going to leave that as MgCO3 solid. Now, at this point, all of the spectator ions are going to get crossed out. And remember, spectator ions is anything you see on both sides of the equation. So we see a 2Na+1 and a 2Na+1 on both sides. So we're going to cross that out. That's a spectator ion. We see an SO4 -2 and another SO4 -2, spectator ion. Now, what we don't cross out is we did not cross out the CO3 -2, we did not cross out the Mg+2, and we did not cross out the magnesium carbonate solid precipitate. So our final answer is going to be anything we didn't cross out. That final answer is the net ionic equation. So in this case, that would be CO3 -2 plus Mg+2 gives us MgCO3 as a solid. So that's going to be your final net ionic equation for that.